down in Antarctica, we may be sampling snow that fell, 400,000 years ago. And so we can take and we can measure the CO2 in that sample and also measure the temperature based on the O18 content. Or we can consult the Oracle. Some people do that. Or some people these days are making up the numbers, right? The guys that head the CRU University, you see the name of them? Penn State University. He developed the infamous hockey stick and gave those numbers up. And I heard somebody say that he's going to be, when he's at Penn State, he's going to be moving from Penn State to State Penn. So that works out. One thing about surface temperatures. Surface temperatures can be very unreliable. The reason being is because we have what's called urban heat effect. And here's an experiment that was done in California, where they had segregated counties into large counties with greater than 1 million people, mid-sized counties or countries which were which were less than 1 million, and then small counties which were less than 100,000 people. And they had, for over 100 years, they had people, send in their temperature data, and then they plotted it out over time. And you can see very, very clear. You can see very, very clear changes in the slopes. Obviously, the very large cities had a much higher temperature increase over time compared to the medium-sized cities and even the small cities. And the temperature of the globe isn't changing, right? I mean, it's going to be the same. So there's obviously air here, and we're getting when you take temperature data from surface temperatures and surface stations that are around large population areas, it's going to be the slope of this is going to be a lot hotter than in reality. Okay, so we have to always keep that in mind when we're looking at data from large urban areas. This is why satellite data is preferred, because it doesn't have that problem. All right, here's some proxy data, obviously, because we weren't around 500 million years ago. So these were taken from ice cores and from boiled cores in the earth. And we did the same process, right? We sliced it up like a bologna slicer, and we did the O18 measurements and the stable isotope measurements and all that. And we determined the temperature and the carbon dioxide levels. Now you want to read this graph by looking over on this side here. This is current, okay? This is our current temperature. The temperature is in red, and the red-brown. And the black is the carbon dioxide. And you can see here what the current temperature and the carbon dioxide levels are. You can see very clearly that back in the Paleozoic era, there weren't a lot of animals around. There weren't any mammals. There weren't any amphibians. There weren't any dinosaurs. There were primitive fish swimming in the ocean, and that was it. At that point in time, we had carbon dioxide levels that were 20 times higher than they are today. The temperature was about, maybe twice as high, I guess, as it was today. And you can see that during the Paleozoic era, when the temperatures were this hot, the carbon dioxide was this high, during the late Ordovician era, we actually had an ice age, okay? And you can see the temperature record just drops to the bottom. They even had glaciation, okay? And so we've got this huge temperature drop all of a sudden, and the carbon dioxide levels are coming down, but they're still high, right? And all of a sudden the temperature pops back up and the carbon dioxide levels are still going down. So what this shows is that we've had a lot of, over the years, we've had a lot of hot temperatures, and we've had some ice ages, and we've had CO2 levels that have been much higher, and they don't seem to correlate well with one another at all. Here's some temperature data that goes back over 500,000 years. And this is from the South Pole, okay, Antarctica. And this is an area called the Vostok area, which is basically a research station set up by the old Soviet Union a long time ago. It's now an international station. What these guys did is they took and they bored a hole down into the permafrost, and they pulled out a core that was over a mile long. You can see these guys over here holding up this ice core. And they did the old bologna slicer trick on it. They sliced it up and they measured the O18 content, and then they measured the temperature, and they measured the time. And what this does is it gives us a time record from current, which is time zero, all the way back to about 400 million years. And the blue line is temperature, and the hard to read yellow-orangish line, or whatever color that is carbon dioxide. And you can see that I pointed out here that we have various ice ages. Okay, and right now we're in an interglacial ice age period. That means we're coming out of an ice age. This is why it's warming. Okay? It's warming today because we're not in an ice age anymore. We're coming out of it. By definition, you have to be warming, right? It's not due to carbon dioxide or man or anything. Certainly man wasn't around here making carbon dioxide. So you can see that we've had, within this time span, we've had about 4 ice ages. Here's one, here's one, here's one, and here's one. These higher points up here represent these inner ice age warming periods, okay, where the temperature goes up. Now you might say, well, look, and Elmore does this all the time. He says, see, look, the carbon dioxide is following the temperature. So therefore, carbon dioxide is causing temperature change, right? They correlate, right? Not so fast. Let's look at this closer. Correlation is not proof of causation, all right? Here, what I've done is I've shown here a map showing the temperature changes over the last, what is this, 100 years or 1,000 years? This is the temperature, as you can see, the global temperature in this gold, it goes up and goes up. And we've also plotted against the U.S. postal chart over the same time. Well, it correlates a lot better than carbon dioxide levels, right? So I guess Albert might tell you, U.S. postal charges cause global warming. That's obviously absurd. And the reason it's absurd is because correlation does not cause causation. You can have in order to have causation, you have to have correlation. But if you have correlation, you do not necessarily have causation. So we have to be very, very careful. Let's take a closer look now at this CO2 and this temperature change. This is part of the ice core that I showed you before, but it's a little bit higher resolution, so we get a better look at it. This represents about 250,000 years ago. And if you look very carefully at the blue line, which represents temperature, okay, temperature goes up, and then the carbon dioxide goes up. Temperature comes down, the carbon dioxide comes down. What happens is the temperature goes up first, right, and then the carbon dioxide goes up. Okay, so do we have correlation there? No. Temperature leads carbon dioxide by about 800 years. Okay, so therefore, what is likely happening is that the temperature is causing the carbon dioxide release, not the other way around. Right? So, and how do you explain that physically? How does physical science explain that? Well, open up a bottle of beer or a bottle of soda. It's carbonated. It's cold, right? Just took it out of the refrigerator. All right? It has dissolved CO2 in it. Now go ahead and put it in the microwave and turn it on for a while. What's going to happen? The carbon dioxide is going to effervesce and degas out of the solution, right? And then by definition, it's going to be in the atmosphere. Okay? It's going to be released into the atmosphere. So this is in fact what happens. What happens is whatever is causing global warming, and it certainly wasn't man back here, because we're 240,000 years ago. Okay, we weren't putting out carbon dioxide. The temperature is going up, and the increase in temperature is causing carbon dioxide, which is dissolved in the oceans. The oceans represent a huge sink of carbon dioxide. When those ocean temperatures rise, the carbon dioxide is liberated, just like the carbon dioxide in your bottle of beer when you put it in the microwave, all right? And so it follows by about 800 years. When the temperature starts to fall for reasons that we haven't figured out yet, then the carbon dioxide starts to go back into solution, all right? So we have to be very careful here that when we look at these graphs that are appear to be correlated, and in fact, CO2 does not, temperature does not, CO2 does not cause temperature increase. It's just the opposite. Temperature causes CO2 release. Now here's a little bit, we're going back in time now about 10,000 years and looking at temperature records. This is from, we had the last ice age, which was about 18,000 years ago. And you can see we're coming out of the ice age. And here's what's called the medieval warm period, which is about 1,000 to 1,300 years AD. And at the same time here, we've got carbon dioxide plotted, which doesn't seem to spikes here, but it doesn't. So if the carbon dioxide was causing temperature rises, you would expect to see the carbon dioxide go up here and not here and so on. So, it's, once again, there's a lack of correlation. So what do we say? We say the temperatures today are not unusual, okay? We've seen that with the large record, the big picture as I call it, that it goes all the way back to 500 million years. We see it with the smaller record here. The Holocene optimum was certainly a lot warmer than it is today. The medieval warming period, which people are trying to get rid of, is a lot warmer than it is today. This is not unusual, the temperature that we have outside. It was much warmer in the past. The past warming is independent of CO2. Therefore, it is not necessary for any current warming to be dependent on CO2 emissions. Okay?